So imaging emission nebulae from your backyard with your DSLR or mirrorless camera. So everybody knows that in order to image deep space objects, you need to drive to a dark site a couple hours out of the city. And you need to bring a tracking mount, a big battery, a telescope, and a camera. And if you're auto-guiding, maybe a guide scope, guide camera, and a laptop. And if you're using a DSLR, then there's a whole bunch of tiny accessories that you'll have to bring that are really easy to forget. And the one you forget is probably the one that makes it impossible to do what you want to do, and you have to go home. And if you're not lucky, you might need coyote or bear repellent. And everybody also knows that you still have to get up in the morning and go to work after staying up all night or sleeping in your car, because clear skies don't care if it's a weekend or not. And one last thing, there's winter. So there's got to be a better way of doing this. And there is. You can actually image certain things like emission nebulae from your backyard or front lawn in Toronto by using a method called narrowband false color imaging. And that was how this was done. This is back in November 2010 from my front door. It's M1, Crab Nebula. It's 5 hours of hydrogen alpha data mapped to the red channel, and 3 hours of oxygen 3 data mapped to the green and blue. But the one problem with this method is you have to buy a dedicated astronomical camera and filters. And so there has to be also a more economical way of doing things, plus an easier way, because this takes hours and hours of processing afterwards too to produce this image. So there's got to be an easier way for the average amateur astronomer who's just interested in dabbling in imaging to produce an image like this from within the city. So the way that narrowband works, narrowband imaging, is that the filters allow a very narrow bandwidth of light to pass. And they usually allow the light to pass at characteristic wavelengths that is light that comes from emission nebulae. And these wavelengths are associated with a quantum change in electrons with the hydrogen atom. We call that hydrogen alpha. And also most commonly too with the oxygen atom, and we call that oxygen 3 or O3. So because the bandwidth is so narrow, it's basically immune to the light pollution that we have in the city. So you can image deep in the city. So this company, STC, asked me to test one of their filters called the dual narrowband filter, and it passes at both these specific wavelengths, and so it allows you to collect data simultaneously for both red and green and blue on a commercial DSLR or mirrorless camera. So that really simplifies things. There are other filters very similar. There's the Optilong L Enhance, and there's also one called the OPT Triad. Now, the STC is a Taiwan company. Other well-known Taiwan telescope companies are Williams Optics, GSO, and Cinta, which owns Skywatcher and Celestron. Now, to give you an idea of pricing, for a 2-inch filter, it's $400 US. The Optilong from China is a nice, reasonable $230. And the OPT Triad, which they advertise as 100% manufactured in the USA, it's an eye-watering $1,100. So it would seem that the Chinese Optilong is the one to get, because they all perform about the same, from what I understand. But I'd just like to remind people, and I'm going to venture into an area where no RASC talk has ever gone. I just want to remind people about the political situation of this planet. China has 2 Canadian citizens held hostage in prison as leverage for the Huawei affair. Hong Kong people have been demonstrating for months now for their lives and for democracy because China is reneging on a treaty that it negotiated with Great Britain when Hong Kong was handed back. And what people may not know is there's a Muslim population in China called the Uyghurs in the northwest part of the country. And millions of them are being interned in what China calls vocational training camps. So when you spend your money, you might want to think about, do you want to spend your money to support a rather odious regime? So I'll just leave it at that. So this is, thank you. So this is what the STC looks like. They have special versions called clip-in models, and they fit perfectly in your Canon or Nikon, in this case my Olympus camera. And this gives you the freedom to use your own lenses, so you don't really need to use a telescope, which might be more advantageous in some circumstances. So it goes right into the camera. And the first thing I did was I wanted to test the transmission profile of the filter and see if it's really as advertised. So I picked up this really ancient 1970s vintage spectrophotometer from a Penn State University surplus. And it was really cheap, it was like 40 bucks. And it was brand new, as you can tell. It even has the original D-cell batteries that run the unit, because it's a portable water testing unit. It's got all the reagents, so you can test and measure the concentration of whatever contaminants that you would find in the water sample. And as a result, because of that, the sample chamber is huge. And that's why I chose this model, because I don't have to modify it. It's big enough to slip those filters in and test them. Whereas typical spectrophotometers have really tiny chambers like this. So this is what I got for the transmission profile of the STC filter. This is what the website advertises as the transmission profile. That's the red part overlaid. And STC is quite good. They actually do a lot of quality control, and they test every filter before it leaves the factory. And that's what the quality control profile looks like. So any differences I would attribute to the fact that I've got an ancient spectrophotometer. It may not be that well calibrated. So I think the specs that show up on the website are probably quite accurate for this filter. So the big question is, how does it perform? Well, this is M42 as you would see it about 3 o'clock in the morning without any filters, just camera in the telescope. And it's actually not bad from the city, because it is a very bright nebula. And you can see Running Man starting to form here. You can see some clouds, some dust clouds starting to come through, but that's about as good as you can get from within the city. This is from a dark site. I believe this is probably from Long Su. And this is only after about 20 minutes of data, and the previous was also about half an hour worth of data. So you can see a lot of things. You can see a hell of a lot more stars, more dust clouds here. And this is what the STC narrowband filter will do. So it's pretty impressive. You can see a lot more detail than you could see visibly, for sure. This is about 2 hours worth of data. And what makes it even more impressive is that the full moon was 90 degrees away, but it didn't really impair the image itself. This is Horsehead with the Flame Nebula. And this, I believe, is lens flare, because the half moon was only 25 degrees away. So this filter might be a little prone to things like lens flaring when you have a really bright object like the moon nearby. And finally, this is the Rosette Nebula. So the filter actually worked beyond my expectations. It really simplifies the process, because you only have the camera to worry about. You don't have to worry about a camera that you have to plug into a laptop to collect data. And it also simplifies processing, because you only have the one set of data to process, whereas if you do it the conventional way, you might have 2 or 3 sets of data to process before you can recombine them into a color image. And that's really all I want to say. I'm kind of a wildlife photographer, and I was after this hummingbird picture for a long time because hummingbirds are really hard to photograph. They're very quick, and their eyesight is very keen, and they're very shy. So I managed to catch this picture this summer. Thanks very much. And questions, please.
Jim.
Yes, Jim, how do you discern the colors from the H alpha and the S2 separately, or can you? Some people want to know where the H alpha is in an object. Where they're both there simultaneously, how do you know which is which?
In the nebula itself, you mean? Yeah, I guess if from experience you would know what colors a nebula would produce, but you know the HA will automatically register on the red pixels on a camera, and then the O3 would be mixed in with the blue and green. So the color sort of happens by itself because you've got a color camera receptive to receiving color of a sort.
So when you process it, were you Photoshop or what are you processing?
You just process it like a color picture, and you can adjust the color a little bit here,
okay.
you know. But that's where the artistic part comes in, where you choose what you feel is the proper color levels.
I noticed in your Rosette image that the stars appeared to be surrounded by dark halos. Is that a feature of the filter, or is that just hasty processing?
Probably not enough data. Yeah, I had a lot of noise, so I had to use all the noise suppression to clean up the image. So if I had more time, that was probably only about 90 minutes worth of exposure. But if you collected several hours worth, then you'd have a better image with less noise, and probably those halos would go away as well.
Right.
Yeah. Yes, Blake.
Hi, Jim. Thanks for that. Have you sent a letter to the U.S. company asking them that you'd like to test their filter?
I don't know what they'd say. I might.
Any more questions? Very good.
Yeah, thank you.